Python is a very slow language. When it starts reading a file, it first parses it into a binary tree of commands, and then it executes one command after the other. So for example, if you have a print hello world, it loads the command for print, it loads the string hello world, then it executes the command print. And it does that step by step. And yet we are using that for data processing. So something must be missing in my statement. But let's have a look at what PySpark does, for example. In Python, you do not execute the data flow. You describe the data flow. Read this table, read that table, join them together, aggregate, produce the result. You only describe the steps. And then when you execute, this is handed over to the Spark cluster and executed there. In our setup, we have the same situation. We use DuckDB. So when you say import DuckDB, what actually happens is the database process gets instantiated. This is really a separate process written in C++, utilizing the entire machine, having none of the limitations of Python, because it runs aside of the Python interpreter. And then we can execute a command like select that table, join with that table, aggregate the data, compute the result, and then all the calculation is done in this high-performance multiprocessing in-memory, in-process database for us, and Python just has to deal with the results. And when you look at the libraries of Python, most of them are in the same fashion. Pandas is written in another compiler language. Every high-performance library is built that way. And the advantage of Python is that it handles loading these natively compiled libraries very easily. And this has also effect for us, because when we execute such a data flow in our Windows and development environment, the DuckDB process must be a Windows 64 version of it. Whereas when we build it and execute it as an Azure function or as a container, it runs as a Linux. So it must run the Linux 64 version of DuckDB. But these have been built, these libraries exist, they are downloaded automatically from a repository. We don't have to worry. All we do is we say import DuckDB, execute our commands, and that's it. So with that we get the best of both worlds, the simplicity of Python and the high performance world of all the libraries they provide. With Python we also use certain syntax variations that are pretty common, but you must know. So the first one is when you call a procedure, a method, you can pass in parameters, positional, you can pass in parameters via their name, and you can even say there is a var arg by position or a var arg by name. All of these combinations are possible within limits. We utilize all of that. Especially we utilize that when we use Pydantic. This is another library provided by Python, which is used to create data classes and then nest them into JSON or deserialize them into native Python structures from JSON. So this is very powerful and also very well integrated in Python. Therefore, we are using that more and more. The next functionality we use is PyArrow. We have the data inside the DuckDB memory. Python does not have access to this process, so it can't really read that from it. And copying that from DuckDB into Python memory would be a lot of waste. And this is where PyArrow comes into play. It is essentially providing us a view from the Python memory into DuckDB and from the DuckDB memory into Python. So when we say create a table in DuckDB, and then we convert that into in DuckDB to a pi-arrow table, this is actually just a pointer. When we now come to the way how we execute these data flows, we have tried multiple ways. The obvious best solution would be streaming them all the way. So while we read the data from a source, we transform that already, we put that into Kafka, and in Kafka is processed further. The advantage of such an approach would be that it doesn't consume any memory, it's streamed through, and it's relatively fast because while we stream the data, we can transform it and load it as well. But here comes again the limitations of Python. So what we do instead is really a step-by-step processing, because the native libraries that Python provides to read data into DuckDB, to process them from DuckDB into Kafka, is much faster than the streaming, at least currently. So our data flows are always built the same way. Copy the source data into DuckDB table. Now it's stored there. Then we can do all our transformations in Python and in SQL. The end result of the transformation might be yet another table. And then we call another method that we provide that says, please copy the entire table data into Kafka. That runs, it streams the entire 100,000 millions of records to Kafka, and then the task is finished. Again, very simple, reasonably fast, especially when it comes to larger data sets, because then this native implementation of the libraries is really more important than the streaming. So when you look at the code, what it actually does is we have a reader. The reader is implemented in a software pattern called adapters, so it's replaceable. This comes in very handy when it comes to testing, because we can read from, for example, Oracle, but then we get the data as it is in the Oracle source database right this minute. And how should we test? It might not have all the test cases, data might have changed, so our expected result is different, or we can do only very high-level tests. That's not good. So we can replace that Oracle adapter with a file adapter, and then we have a sample set of data that tests our entire code. And also at the endpoint, we can replace the Kafka producer by a dummy producer that keeps all the data in memory, and then we compare if the target is the expected one. So therefore, that reader is one class. You simply instantiate it, you give it a couple of information about data governance, you specify what you want to read, or you even create a schema, meaning the table structure yourself. Both is possible, it depends on the source system. In Oracle, for example, you would not create a structure from scratch because you read a table, you execute a SQL statement, you have that structure already, whereas when it's a REST endpoint or a CSV file, you have to build the structure yourself. And the reader, all the reader does is writing the data into DuckDB so that you can process it further. On the output side, we have the producer. Again, producer comes in different flavors. The only relevant for us is the Kafka producer because it writes to Kafka. But a Kafka producer, or a producer in general, is just a connection to the target. So theoretically, we could load multiple tables via that single connection. We could load different data structure via that connection. We could load first this table and then that table, or both in parallel. To enable all of that, you can say to the Kafka producer, please create me a target for the following table with the following structure. And this target object is then the holder of the table pointer.